My name is Tyler Sheevy. I'm a product engineer on the Runtime SDK for Java. And for the past year and a half or so, I've been kind of an internal advocate for a Kotlin programming language within the Runtime team. So it's really a pleasure to get this opportunity to talk to you about it today. So on the agenda, I thought that for the first few minutes, I'll go through some slides and give a small overview of Kotlin for those of you who have maybe never heard of it before. And then the rest of the demo theater, I'm just going to show some code examples of some of Kotlin's features and why you might want to use Kotlin in your Java and Android projects. Little disclaimer, if you've already seen the webinar that I gave a few months ago with Esri GeoDev, a lot of this is going to review for you. If you haven't seen that, the code for this talk and that webinar and the talk on YouTube are right there for you. But feel free to make this talk more interactive. Feel free to ask questions while I'm talking or save them for the end. All right, so jumping right in, what is Kotlin? So Kotlin is an object-oriented, statically typed language just like Java, except it also has some functional constructs. And while that isn't unique to Kotlin, it makes it stand out from Java. And it's also interesting to see how Kotlin blends the two paradigms of object-oriented programming and functional programming, which we'll see in the examples. So Kotlin is developed by JetBrains, which you probably know as the creators of the IntelliJ IDEA, IDEs, or Android Studio. And it's also open source under the Apache 2 license, so you can contribute to the language as well. So one really great feature about Kotlin is that pure Kotlin can be compiled to bytecode for running on the JVM or Android. It can also be compiled to JavaScript or even native code with the latest releases. And then as of Google I/O 2017, Kotlin was made a first-class language for Android development. And it's important to note that Kotlin is targeting more platforms than just Android as well. It's actually becoming a very popular language on like server backend solutions as well. So why Kotlin? So if you ask JetBrains, the first thing that they'll tell you is that it's because it's pragmatic. So JetBrains didn't set out to create some new flashy, esoteric language from academia to save the world. Instead, they really liked Java, and they wanted to keep all the good parts of Java and just fix the bad parts. So that's really the first goal of Kotlin. And then that kind of leads into the second part, which is that Kotlin is interoperable. So JetBrains, their products are written in Java and JavaScript. So when they created a new language, they didn't want to rewrite all of their products in a new language. Instead, they wanted that language to be able to use the existing languages. So Kotlin is 100% interoperable with Java. So that means you can use any Java library in the Java ecosystem in your Kotlin project, and vice versa. You can use any Kotlin code in your Java projects. And the same goes for JavaScript if you're targeting JavaScript. Next, it's readable. So Kotlin basically removed all of the boilerplate code that you might write in Java that the compiler could figure out for you. And that makes the language more concise. And then those functional aspects I was talking about with Kotlin can make the language more expressive. And it's really this interplay between conciseness and expressiveness that makes it readable. And we'll see that in the examples. And then lastly, it's safe. So I mentioned Kotlin is statically typed, so that helps find some bugs before they occur at runtime. And then the other thing is that Kotlin has null safety, so you can avoid the dreaded null pointer exception from Java. All right, so with that, I hope that overview kind of helped you get a feel for what Java or what Kotlin is. For those of you who might not have seen it, I'll switch over to the demos. 1 second. All right. So I have 12 demos for you, little code examples. The first half are going to be kind of comparisons between how Kotlin does things with Java, and then the second half are going to be on features that really only Kotlin has. So we're starting here, of course, with Hello World program. So first thing to note is that coming to Kotlin from a Java background, you're going to notice things look really familiar. And so in the Java Hello World program, which I have here in comments if you haven't seen that before, you'll notice we have that public static void main method, and we have the same kind of thing for Kotlin. But I want to point out some of the differences. So the first is that you'll notice that we don't have to wrap the main method in a class. And that's because Kotlin has top-level functions. And they're basically called just like Java static functions, which is why we don't have the static keyword. The other thing is we don't have the public keyword either, because everything in Kotlin is public by default. We also don't have void. Instead, this main method returns the type unit, which is, so the return type is indicated with this kind of colon syntax for both variables and, or for both arguments and the function type. And we're actually returning a object called the unit, which we'll talk about why that is a little bit later. So void is now unit. And then you'll also notice that println is imported by default, so we don't have to write system out println all the time. And we also don't have to write any semicolons. So we're really cutting down on some of the boilerplate that we have to do with Java. All right. So let's talk about types. So in Java, you know that we have primitive types, such as like string, long, ints, bools, and so on. And then each of those primitive types has a corresponding object type. And the object types have methods on them, but the primitive types don't. And sometimes, depending on what logic you're trying to do, you might have to convert between the two. And that can be a tiny bit of a nuisance. And so Kotlin doesn't have primitive types. Instead, it just has the object types. But you can still instantiate or set a variable using this literal value to create that object. Now, you'll notice here if I hover over, it's giving me a hint that this is redundant. And that's because I can just remove that declaration of the string type because Kotlin has type inference. So anytime the compiler can figure out what the type of that variable is, you can omit that type declaration. The other thing I'll mention is that there's no special array syntax like there is in Java. Instead, you're just creating an instance of an array class that has a generic type. And then there's functions within the standard library of Kotlin that can help create those. Next, I'll point out these var and val keywords. So var creates a mutable variable, just like a normal variable in Java. And then val is like Java's final keyword. So it creates an immutable variable, one that you can only set the value of once. And really the only difference between val and final is that in Kotlin you have to declare explicitly that you're using either a var or a val, whereas in Java you have the chance of maybe accidentally omitting final when you'd really want to use that. And it's this subtle kind of default that kind of pushes Kotlin developers to favor immutable values, which is a good practice because immutable data is a little bit easier to reason about in programs. So that's types. Now I want to talk about control flow. So you notice here that we have a if statement, and it looks just like Java. So anything that Java does well, Kotlin doesn't try to fix. It doesn't change. So that's the exact same. Things change a little bit when we want to return a value from an if expression. So Java, you know that we have a ternary operator. So based on the condition, you can either return one value or another. But in Kotlin, there's no ternary operator because this kind of breaks down when you have lots of nested conditions. Ternary operators can be a little harder to read in that case. So instead, Kotlin has just reused the regular if expression. And when you have more branches or more conditions, it still is clean and easy to read. So what's going on here is in these conditions, you can see that the last line in the braces of each branch is the return value. So this would be the return value in this branch, and so on. And since Kotlin is smart about type inference, it can see that because these are all strings, then the type of this temp variable should be a string too. So I don't have to set that. So the type inference is fairly robust. Next thing is for loops. So these are pretty much the same as in Java. Here I'm just taking an integer within the range 0 to 10 and adding those to another list. You'll notice that I have a range operator that's new in Kotlin, and that just is slightly more concise. Although this for loop is just as powerful as Java's for loop. You can set the step size and so on. I just haven't shown that here. The other thing I want you to notice is that I've used this mutable list. And that's because if I switch to just the default list, you'll notice I no longer have that add method. And that's because the default list is immutable. So this is, once again, a way that Kotlin has kind of promoted the use of immutable data structures because they're a bit easier to reason about. And then, of course, just like in Java, you can loop through any iterables using this syntax with in. And that's because in Java, you do this with a colon, but that's reserved for type declarations in Kotlin. All right, so in the last example, you'll notice I didn't mention switch statements. That's because in Kotlin, there is no switch statement. Instead, we have this expression called when, which is kind of like a switch with superpowers. Here, you'll notice that I'm creating a random integer between 0 and 100. And then in this when expression, I have conditions on the left and return values on the right. So when I get this random value, it's going to go through each of these conditions in order. And the first one that it matches, the value on the right will be returned and set to the variable grade. And so the only thing that these return values have in common is that they all extend the top type in the Kotlin type system called any, which is equivalent to Java's object type. So we can use that type inference there to say that's any. And you can also add an else condition. It's basically a form of pattern matching. And we need the else in this case because we're setting a value. So if none of these conditions match, we still need to be able to initialize grade. So that's why we have else there to handle that case. So I'll note here that in a Java switch, you wouldn't be able to do this. You'd have to use an if-else, lots of if-else branches. Because Java switch can't check against conditions like we're doing here. And I also want to note that you can even match against void return values by checking for that unit type. So that's why we kind of return unit instead of this extra invented thing called void, because we can actually return that unit object and find out if we called a function that returned void. Now, there's another form of the when expression that can take an argument. And so basically what's happening here is that I'm passing in grade, and then I'm matching against any of the values on the left. Notice I can even match against a list of values, and then I'm going to do the thing on the right. Notice here that I can also check for if this variable is a type of an exception in this case. And then once I find that out, I don't have to cast again to exception. That smart casting is coming into play there, and I can access message easily. And in this case, I don't need an else, because if grade doesn't match any of these conditions, then it will just continue through. No problem there. And then once again, a Java switch wouldn't work here because Java switch can only compare against values of the same type, and these are all different ones. The last thing I'll mention is that you can even pass in null values here, whereas in a Java switch, it would throw a null pointer exception. So we're avoiding that as well. Okay, so yeah, so when expressions are basically a really powerful new switch statement, and they're also super concise. Cuts down a lot of boilerplate. All right, so moving on. So we're using an object-oriented programming language, of course, so we should be able to create classes. So this is how we do that in Kotlin. In our type declaration, I'll mention that classes are also final by default in Kotlin. So in order to be able to extend a class, you actually have to opt into that using the open modifier here to make it extendable. So if you're writing libraries, you want to be able to have your users extend your class, you'd have to do that. Now, looking at the type declaration here, notice it's a bit different than in Java. Usually you just declare the class name, and then you'd have a primary constructor down here in the body. Instead, that's been kind of pushed up to the top level in Kotlin, and what that allows you to do is kind of to, at a glance at the top level, know kind of the minimum structure of that class. So here we have the primary constructor and the class declaration all in one. And there's a lot you can do here, actually. So when you declare these fields, when you declare these arguments in the primary constructor, you're actually declaring them as properties in Kotlin. And depending on the val or var keyword, you can actually make those read-only, which would only have a getter, or also writable, so you can have getters and setters. And then also you can use those access modifiers like private and protected to control further like visibility. So that's your primary constructor. If you want to do any initialization after constructing an object, you can use the init block for that. If you want a secondary constructor, you can use the constructor keyword, and then you have to reference that primary constructor. Whereas in Java, you'd have to call this on the first line of a constructor. This is a bit more explicit. And then actually the example here, I'm using kind of a new constructor for an overload constructor, like you do in Java. But we'll actually see a little bit later that Kotlin has a way of kind of avoiding even needing to do that. But I'm just showing how you might use a secondary constructor here. Now, if you want to have static properties, then you use a companion object. So the object keyword is also how you'd create a singleton in Kotlin. And that kind of makes sense because this object is really the object representing the class type itself. So any static values are going to be put in that object. And then if you want to override any methods from the class that this class extends, then you can do that using the override keyword, which is a little more explicit than Java's override annotation. Here I'm also showing another nice feature of Kotlin, which is string interpolation. So instead of having to add pieces of string together, you can instead just inject the values of variables into the string using this nice syntax. So here, notice when I'm creating an instance of this car class, I don't have a new keyword. We don't need that. And still no semicolon. So again, reducing some of the boilerplate. And then I can access those fields that I declared as properties because they are truly properties in Kotlin. I can print out the read-only property, and I can also modify that settable, mutable property. And then I can access static properties of that class, just like I would in Java using the type name. All right, so in that previous example, in representing that car, you'll notice that essentially we only had that class defining a bit of data. In other words, there was no complex logic going on in that class. And so in Java, we'd usually represent that in something like this, which is known as a Java bean. So a typical Java bean would have the class declaration, you give some fields, a primary constructor which takes those fields as arguments and then initializes them, some getters and setters, and then you'd usually override the equals hash code and toString methods of the Java object type. And this is really just a lot of code just to define a class that really only holds data for 2 fields. And that's kind of why Java gets criticized for its verbosity. Now, most of us know that a lot of us don't actually write this code ourselves. Instead, we can use smart IDEs like IntelliJ IDEA or Android Studio to generate this code for us. But the problem is, how do you know that this is the auto-generated code? To do that, you would have to scan the whole class and make sure no one wrote any custom logic in there. And that might not be very easy to do when you have lots of fields. So JetBrains, being the creator of the IDEs that generate this code for you, they thought in their language, the language should handle this auto generation for you. So in Kotlin, a Java bean is done like this. It's a one-liner. So we use this data modifier on a class, and that tells you that it's going to auto-generate equals hash code and toString for this class. Now, if you want to override those auto-generated methods, I can still do that, but I still get an idea of which ones are auto-generated and which ones have custom logic just at a glance. So a lot better and easier to maintain there, especially when you might be adding new fields or removing fields, and you don't want to also have to worry about changing auto-generated code. And so all of these auto-generated ones are going to have sensible defaults. In this case, if I create an instance of this customer, then it's going to print out a string looking like this, which just gives a nice readout of all the properties. And this even works for nested data structures as well. Okay. Another really powerful feature of Kotlin is null safety. So you'll notice in this declaration, I have some properties that have this syntax with a question mark, and that indicates a nullable property, a nullable type. So basically, I'm saying I can create an employee, and they have to have a name, but they don't necessarily need to have an email or a car, so I can set those to null. Now, if I want to print out that email, you'll notice I get a compiler error because length on a string is only defined on a non-nullable string. You wouldn't be able to compute the length of a null string. So in Java, this would be a warning. In Kotlin, it's a compile error. So we're doing better to catch those null pointers. Now, in Java, if you want to get around this or check this, you would surround it in an if condition, checking that the value is not null. Now, if I do that in Kotlin, you'll notice that I still get a compile error. And that's because Kotlin is smart, and it knows that because this property is a mutable variable, then in a multi-threaded application, it's actually possible that the value of email could be set to null right after we checked that it wasn't null. So we still need to do something about that. Now, you wouldn't even get a warning in Java here, and you'd still get that null pointer. So Kotlin's doing a lot better there. So one way we can get around that is to first create a new variable that's immutable of that email, and notice it's still this non-null string type. But when I do that check, now Kotlin knows that because this is immutable and I've already checked that it's not null, I can smart cast that type to a non-nullable string, and now I can print out the length. So now this is still a little bit verbose, and we're trying to cut down on boilerplate, and this can be even more verbose when you have lots of nested, possibly null structures that you're going through. So we can do a little bit better with this safe operator. So that's using this question mark dot syntax. If you use this, basically what it's saying is, I'm going to go through this condition. If I hit null, then I'm going to stop, and I'm going to return null. And so this is going to print the string null. Otherwise, I'm going to continue through, evaluate the whole expression, and then print the length. And this really shines when you have to search a deeply nested structure that might have null values in there. You can chain these safe operators so that at any point, if I go through here and I hit null, I can just print out null and not throw a null pointer. Otherwise, I can continue through and get the data that I want. And so in most cases, you're not just going to want to print out null. So instead, you can provide an alternative in case of null using this Elvis operator here. So in this case, if employee.email is not null, I'll evaluate that, print it out. Otherwise, I'm going to use this default value here. Okay, another thing is optional arguments. So we talked about that secondary constructor I made being an overload constructor. And this actually allows you to not have to create those in most cases. So here I can actually define a default value for these arguments. And this works for functions or class declarations. So basically down here, I can create a point and not pass any arguments, and then it's going to use those default values. Otherwise, I can just provide a subset of the values, and the other ones will use the defaults. And I can also use named arguments. So here I'm setting specifically just the Y argument and using the defaults for the others, and Java can't even do that. So there's some new things with Kotlin. All right, now I have 4 more examples to try to make the best use of time. And these will go into the functional aspects of Kotlin. So this is an example of what's called an extension function. Basically, I'm defining a new function called swapEnds on a generic list type, which returns a new list of the same type with the ends swapped. So really, I'm defining new behavior for a list. So these functions you can put on classes that you haven't even authored. Somebody else made them in a library. So in the implementation, I'm first checking if the list is empty or its size equals 1. In that case, I'm just going to return the same list. It's already swapped. So the this refers to the list that I'm calling this function on. Otherwise, I'm going to create a new mutable list, swap the ends, and then return that. And that'll be my return value. So here, I'm basically taking a list of strings, and then I can just call that extension function on that list, even though that function isn't normally defined on a list. Now, because of that interoperability, that 100% interoperability with Java, you can still call this from Java. And to do that, it would be called as a static function in Java. So you can use this annotation to create basically a class name called listUtils in this case. And then that function is going to live in that class, and you can just pass the list that you want to operate on, and it'll behave just like this. The other thing I'll show is that I have another extension function called add, which I'm using on an integer, which takes another integer and just adds them together. Notice that there's a little less boilerplate code here because I can omit the braces if it's just a single expression. So that goes for all functions. And that's going to give me the same syntax that I was showing here. But the other thing is I've added this infix modifier. And this allows you to get a little more interesting syntax. Here I don't have to put the dot or the parentheses around, and I get this kind of almost natural language looking syntax. And unfortunately, you can only use this in Kotlin. If you're using this function from Java, you'd still have to print this. But in Kotlin, you can make some really cool looking APIs using this kind of natural language syntax. All right, so this is higher order functions. So because Kotlin is functional, you can actually pass functions into functions. So I'm going to be showing that. So basically here I have an inventory, which is essentially a map of strings to ints. And again, I'm using that infix, another infix function. to create that. And then I have a map function, which is going to basically take the entries in this map and then print out a string. So let's look at how map is defined in the standard library. So we'll notice it takes one argument, and it's actually a function type argument. So to denote that, you would give the input type, that argument type, and then the return type, just like this. So it's taking entry type, and it's returning some other type. So if I go back, notice that here I can pass in a lambda to create that function that I'm going to pass in. In this case, I'm using that taking an entry and printing out a string. Now, some syntactic sugar is I can also get rid of those parentheses. If the last argument in that function is a function, then I can just use this nice syntax, which almost looks a bit like a closure. And here I can chain functions together without like a Java stream and continue on. And the other thing I'll mention is that if a function only takes one argument, then you don't actually have to explicitly give it a name. Instead, you can just refer to it as it. Okay, two more examples. Pretty close to time, but keep going. So in this case, basically we're taking a class that has like an empty constructor and a lot of properties that you might configure. So you might see this in like a builder pattern in Java. Otherwise, you might have to use this kind of redundant syntax, which you keep setting properties, and you keep having to say like JSON dot this, JSON dot this, and just gets redundant. Instead, in Kotlin, you can use this apply function, which is called the receiver type function. And notice that I can somehow do things in this closure that I can normally do on a JSON object. So if I go into the type declaration for, the function declaration for apply, notice that it's also taking a function type, but I have this interesting syntax, which is called the receiver type, which is basically, I want to pass in function, which is going to kind of inherit the scope of the type that I'm calling it on. So if I go back, then when I call this on an instance of JSON, then the this in the lambda is that JSON object. So I can do whatever I would normally do to a JSON object in this lambda, and it will all just kind of be applied at once and set into this variable. So if I was to print out preprint here on JSON, where it was initially false and I said it's true, it would print out true. Okay, last thing. If you combine extension functions and receiver type functions, you can get this really cool pattern called type safe builders. And this is how you create DSLs in Kotlin, or domain specific languages. So here I'm using this perfectly valid syntax in Kotlin to create an HTML document. And I can use, basically all this is using is those extension functions and receiver types, and it all builds up into a static HTML document. And I can even use other kind of like control flow expressions in my kind of markup syntax, which you wouldn't be able to do in like HTML, for example. So I have like the implementation of this down here if we want to go into that with the questions. But this is really powerful, and you'll notice that in things like JavaFX applications, you can actually use these to build like UIs or type safe CSS builders that can be dynamic. And if you want to learn more about that, you can look for the library called TornadoFX. All right, I know I'm over time, so I'll cut it there and I'll take questions. Thanks very much.